Faraday. Michael Faraday was the first scientist who described the quantitative aspects of electrolysis. He gave two laws of electrolysis. After his extensive investigations on electrolysis of solutions and melts of electrolyte, Faraday published his results during 1833 to 1834 in the form of the following well-known Faraday's two laws of electrolysis. First law: the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. Second law: the amount of different substances liberated by the same quantity of electricity passing through the electrolytic solution are proportional to the chemical equivalent weights, that is, atomic mass of metal divided by number of electrons required to reduce the cation. There were no constant current sources available during Faraday's times. The general practice was to put a coulometer, that is, a standard electrolytic cell, for determining the quantity of electricity passed from the amount of metal, generally silver or copper, deposited or consumed. However, coulometers are now obsolete and we now have constant current sources, and the quantity of electricity Q passed is given by Q equals to IT, where Q is in coulombs when I is in ampere and T is in second. The amount of electricity or charge required for oxidation or reduction depends on the stoichiometry of the electrode reaction. For example, in the reaction Ag plus electron gives Ag, 1 mole of the electron is required for the reduction of 1 mole of silver ions. We know that charge on 1 electron is equal to 1.6021 into 10 to the power minus 19 coulomb. Therefore, charge on 1 mole of electrons is equal to Na into 1.6021 into 10 to the power minus 19 coulomb. This implies that C is equals to 6.02 into 10 to the power 23 mole inverse into 1.6021 into 10 to the power minus 19 coulomb. This implies that C is equals to 96487 coulomb mole inverse. This quantity of electricity is called Faraday and is represented by the symbol F. For approximate calculations, we use 1 Faraday equals to 96500 coulomb mole inverse. For the electrode reaction, Mg plus 2 electron gives Mg and Al plus 3 electron gives Al. It is obvious that 1 mole of Mg plus 2 and Al plus 3 require 2 mole of electrons and 3 mole of electrons respectively. The charge passed through the electrolytic cell during electrolysis is equal to the product of current in amperes and times in second.